We know that excess amounts of greenhouse gases are the driving force behind climate change in the atmosphere. But how are these emissions affecting the world's oceans? The ocean covers 70% of the globe and is responsible for absorbing 30 to 40% of the atmospheric carbon dioxide emitted by humankind since the beginning of the Industrial Revolution. But what is the effect of all this carbon dioxide? Let's take a deeper look at what happens after the carbon dioxide is absorbed. Carbon dioxide dissolves in water to form carbonic acid. Each molecule of carbonic acid can then release one of its hydrogens to form a bicarbonate. A bicarbonate molecule can further release a hydrogen ion to form a carbonate ion. Now you have an excess amount of hydrogen ions floating around in the water. But why is this important? Those excess hydrogen ions increase acidity and decrease the pH of seawater. The pH scale ranges from 0 to 14, with 0 being acidic, 7 being neutral, like distilled water, and 14 being basic. It is important to note that the pH scale is logarithmic, not linear, meaning a change of pH from 8 to 7 is equal to a 10-fold change in acidity. The average pH of the ocean has dropped from 8.26 to 8.14 since the beginning of the Industrial Revolution. And although that may seem insignificant, remember that the pH scale is logarithmic, so this change actually equates to a 30% increase in acidity. The rate at which the pH of seawater is changing is the greatest cause for alarm. The rate is most similar to a greenhouse event recorded at the Paleocene-Eocene boundary over 55 million years ago. This event was presumably the result of a massive volcanic methane release of about 2,000 gigatons of carbon over approximately 10,000 years. To put our impact into perspective, from the beginning of the Industrial Revolution, humans will have released 5,000 gigatons of carbon by 2400. The fossil record shows a massive extinction event of many bottom-dwelling species following the methane release. So what will the impact be on biodiversity this time around? Now going back to some chemistry, many organisms utilize those carbonate ions mentioned before to make calcium carbonate, a compound made of a calcium and a carbonate ion as shown in this equation. The organisms that depend on calcium carbonate range from corals to crabs to mollusks. Unfortunately, many of the carbonate ions available in the ocean are recombining with the highly reactive hydrogen ions present in the water, meaning there are less carbonate ions available for organisms that need them, for growth, repair, etc. Corals are particularly sensitive to acidity changes. When reefs stop growing or become more fragile, this destroys some of the most diverse ecosystems known on the planet. Fish have been studied to show signs of confusion, anxiety, and struggle to find food, as well as weakened immune responses. Pteropods, specialized free-swimming pelagic sea snails, have already showed signs of dissolved or brittle shells. And most greatly affected seems to be the larval stages of many of these organisms, with higher mortality rates already observed in areas of upwelling, where those deep CO2-rich waters cause a drop in pH. But it's not just corals, crabs, and mollusks affected. Besides macroorganisms, single-celled organisms such as foraminifera and coccolithophores are at the basis of the food web, and some of the most affected by ocean acidification. Change in pH greatly affects their metabolism and ability to make their calcium carbonate shells. Coccolithophores specifically are single-celled algae that secrete calcium carbonate plates. They are especially important in marine ecosystems because they are primary producers. These guys are also super abundant, and are known to secrete a chemical that aids in the formation of clouds. Some scientists believe that a threat to coccolithophores could result in a reduced cloud coverage over the ocean, leading to less reflectivity of harmful UV radiation from the sun and ultimately leading to an increased rate of surface warming. Other negative effects of the ocean acidification include impairment of acid-base regulation, reproduction, respiration, decreased metabolic rates, unusual behavior, and overall increased mortality. All these are complex problems, but these changes in the ocean affect us too, and future decision makers must consider the impact of ocean acidification at the species and ecosystem level. Although ocean acidification is not climate change per se, it has commonly been referred to as the other carbon dioxide problem. It is a global problem that needs to be talked about to find global solutions. So, what can you do to help? First, you can spread the word. Thanks for watching.